So we've seen quite a few fractions with radicals in them at this point. What we haven't seen yet is a fraction with a radical in the denominator without something in the numerator that it cancels with. Unfortunately, we're not allowed to leave that radical in the denominator. This fraction is not fully simplified. If you're at all curious why, feel free to watch the theory video at the end of this playlist. Now, all these steps over here on the right, these come from the orange checklist passed out at the beginning of the unit. If you don't still have yours, feel free, raise your hand. I have tons of extras. That orange cheat sheet will be a tool you can use on the next test. So make sure you're comfortable using that. It does lay out all the steps for a process known as rationalization. What rationalization does is it will get rid of that root 7 from the denominator. The first thing we need to recognize is, oh, we have a denominator, and it's one we're not allowed to have, a root 7. So that's done. That's just identifying the fact that there's a problem. Step 2, multiplying by 1. You can multiply any number by 1, and it doesn't change the value. In practice, we don't usually write that 1, but it's helpful the first time to see the process. The third step is to rewrite that 1 as the denominator over itself. So if you'd like to do this by rewriting, feel free. But we're going to rewrite that 1 as the denominator over itself. Where the real work comes in is this multiplication piece. We want to multiply those two fractions together. So 4 times root 7 is 4 root 7. And the square root of 7 times the square root of 7, I'm going to pull some scratch work over here. Square root of 7 times the square root of 7 is the square root of 49. But we know the square root of 49 is just 7. So altogether, rationalizing this, we get a 4 root 7 over 7. Note that the last step here, to simplify the numerator and denominator, we don't have any terms that cancel, so we don't have to worry about that. But notice what I have now is a fraction where my denominator is the whole number 7. So we got rid of the radical in the denominator. Let's take a look at another example. Here we have the square root of 5 over the square root of 2. Now we have 2 radicals, but it's the root 2 that's the problem. Square root of 5 is okay in the numerator where it's at, but the square root of 2 is not allowed to be in our denominator. So when we identify that denominator, our first step, keep in mind what we're talking about there is just the bottom part of the fraction. Root 2 is our problem. Multiplying this fraction by 1, because again, you're always allowed to multiply by 1. In practice, in the next 2 examples, we're going to omit that step, but it's important to know why we're allowed to do step 3, and it is that multiplication by 1 that lets us do it. So jumping down to step 3, rewriting as denominator over denominator, we have a root 5 over root 2, and we're multiplying by that root 2, again, the denominator. So multiplying these 2 fractions together, the square root of 5 times the square root of 2, that is going to be root 10. And then in the denominator, a little bit of scratch work here, the square root of 2 times the square root of 2, well, that's the square root of 4, but the square root of 4 is a number we know. The square root of 4 is just 2. Like the previous example, in this one, nothing simplifies, so that is a final answer, root 10 over 2. So let's kick it up just a bit. Now notice I've got a 6 over 18. Keep in mind that this is the same thing as the square root of 6 divided by the square root of 18. That's our quotient rule. And we can go back and forth between these 2 forms at our leisure. So depending on which one makes more sense, we can rewrite a radical with a fraction as a fraction of radicals. But I'm going to stay in this form because 6 over 18 can actually be reduced. 6 over 18 is the same thing as 1/3. The reason it's important to look for reducing first is if I just went right ahead with what was given, I would have to multiply by root 18 over root 18, that original denominator, and that would have given me some fairly large numbers. But when I reduce first, I wind up with a 1/3. 1/3 is much easier to deal with than 6/18. So I recommend taking a look at your fraction before doing any work. Make sure it's already as simplified as you can get it. So now I'm dealing with 1/3 as my fraction. And if it helps to think about it this way, well, the square root of 1 is just 1, and the square root of 3 is root 3. Rewriting it that way makes it pretty clear that I have an issue in my denominator. There's a root 3 in the denominator, so I can multiply by 1. Again, in practice, we don't usually write that step, but that 1 allows us to say, hey, root 3 over root 3, I'm allowed to do this, because root 3 over root 3 is just 1. 1 times root 3 is going to give us a root 3. Root 3 times root 3, well, that's just a root 9, but the square root of 9 is 3. So that was our step 4, the multiplication. Note that once again, we don't have anything that cancels here, so that is a final answer.